So you should have completed the journal section 6.0. Okay, we worked on it in class before break. We worked on it in class on Monday. So if you have not done it, that is your responsibility. It's your responsibility. So calculus is divided into two parts. There is the differential part, which hopefully we have mastered at this point, because you're going to need to build on what you have learned. And then there's the integral part, which is what we're going to start talking about now. The exercises that I had you do when you were doing section 6.0, the moving man and the calculus grapher, were designed to help you understand the connection between the area under the curve and the antiderivative. Okay, an antiderivative is a word we're going to use right now, and eventually that word will become integral, sort of. Okay, and to show you that we can calculate the area under the curve by adding up smaller sections of the area under the curve. So if we look at the graph that was back in example 1, of section 6.1, so what you're supposed to have read today. And the graph looks something like this. It's a velocity versus time graph, and the graph looks like that. Okay. And in this case, we happen to know that v is equal to t squared. You can just copy the graph. If it's not in your book, don't worry about it, just write it down. Okay. And I've got some intervals on my time axis. If I want to find the area under that curve, I can make little triangles. Rectangles, they're rectangles. Okay, or I can make bigger rectangles. It's a little easier to see if I make bigger rectangles. Okay, but the problem is, when I do that, is that there are places where the area of my rectangle is above the curve. So my rectangle is including area that isn't technically under the curve. And there are also places that contain area that's under the curve, but it's not inside any of the rectangles. So over here, I'm over-calculating, and over here, I'm under-calculating when I do my estimate by finding the area by making the rectangles. Well, you kind of sort of do that. That is one option. And you need to remember, when I was talking to you about the RAM program a couple minutes ago, is that this is really it's a stepping stone to where we're going to end up with calculus. Okay, we're doing this so that, again, you understand that this is one way that I can do it, but eventually what I'm going to do is I'm going to take a limit where the width of those rectangles goes to 0, and then I'm going to add them all up. And when I do that, I don't lose any of my area. Okay, and that's actually going to be what an integral is when I let the number of rectangles that I have go to infinity, so their width goes to 0, and then boom. We're actually taking an integral and we're actually getting an accurate answer. Okay, so in making these rectangles, we really end up with, excuse me, 3 different choices. If I just draw my curve again, and in fact, I'm going to draw it again over here so that it's really big. I can draw 3 different kinds of rectangles. I can draw a rectangle where the left edge is touching the curve, okay, which is something that you should have read about that's called LRAM. I can make a rectangle where the middle of the rectangle touches the curve, and that's something called MRAM. Or I can make a rectangle where the right part of the rectangle touches the curve, and that's called RRAM. And depending on the situation, depending on what the curve looks like, I may want to use a particular one of these choices. Okay. So the program that you have in your calculator lets you choose the number of rectangles. And one of the things we're going to look at is that if we make the number of rectangles big enough, then the answers that we get for LRAM, RRAM, and MRAM are going to converge on a single value. That's one of the examples that we're going to do today, okay? But I'd like to start by looking at example 1 because not everybody had a chance to use RRAM or use the RAM program when they were doing 6.1 because I didn't transfer the program to you yet. So if you don't have the program, why don't you slide your desk next to somebody who does? Okay, I think it's just the 2 of you. All right. And then let's look at exploration 1. And it was a little surprising that nobody emailed me and said, hey, I need this program. Just saying. All right. So situation 1 says, I don't know what it really says, but basically we want to graph 5 minus 4 times sine x over 2. And does it tell us what the window should look like? Yeah. So the window should be 0 to 3 vertically, horizontally, and 0 to 5 vertically. So why don't you start by just graphing that in your calculator? And it's really important when you're dealing with the RAM program that y1 is the function that you want to apply the RAM to. Okay. And you should probably make sure, of course, that you are in radian mode. Okay. And so you should get something that looks like that. It actually kind of levels off a little bit more at the bottom. Right? Okay. And then another thing that you have to know when you run the RAM program is, well, why don't we all run the RAM program for a minute here? Okay. So go to Program, choose RAM. It'll say Program RAM on your calculator screen. And when you hit Enter, it should say A. Okay. A is over here where we're going to start our interval. So what should A be equal to in this situation? 0. Okay. And then B is the other end of our situation here. So what should B be equal to? 3. If you put 0, if you put A equals 0, then you hit enter and B will pop up. And then you put in your 3 and you hit enter. And then it says no subint. There's a period there. It's not, it's number. Okay, so it's the number of subintervals. And how many subintervals are we supposed to make according to our exploration 1? 3. Okay, so that means I'm going to break this up into 3 rectangles. Okay, so you would let subint be equal to 3. And then if you hit enter, it tells you left, mid, and right as your values. Right? Does that pop up on your screen? Okay, we're going to hang on to those values for a minute. So let's look at what would happen if we drew, for instance, the rectangles with the left side meeting the curve. Okay, so this would be my first rectangle, right? I'm going to have 3 of them, so each one of them is going to be 1 unit wide, but it's got to touch the left edge. My second one is going to look like this, and my third one is going to look like that. And that's going to be my left, or what I call my LRAM. And what do you get for that? I can live with 9.716. They're not going to be close enough that we're going to have to go out to like 6 decimal places or anything. Okay. All right. So what am I doing here? Overestimating or underestimating? I'm overestimating. Okay. Now, I can also do my mid, which I call MRAM. And that means that the middle point of my interval is where I meet the curve. So these are going to look like that. And what do we get? Okay. And then we'll come over here and we'll do right, or RRAM. And that means it's the right edge of my interval that decides what the height is going to be. Okay. Is that overestimating or underestimating? Underestimating. Okay. And what do we get for that value? It's 5 point something, right? Okay. So in this situation, for number 1 of exploration 1, we find that LRAM is bigger than MRAM is bigger than RRAM. And just because, as always, I am an omniscient narrator, is this function increasing or decreasing? It's decreasing. Just keep that in mind. Okay. All right, we got it? We see how this works? Okay. All right, let's try number 2. Number 2 gives us a different function. What's y equal to for number 2 of exploration 1? Is the plus 3 inside the parentheses? Does it look like that? Okay, so remember again that this has to be equal to y1 because that's where the program is going to look for the function. Okay, so start by graphing it. What's it going to look like? And wait, and what's the graph? It's the same. Yeah, I think so. Yes, it does actually say in the same window. Whoops. Graph. So we get something that looks like that. And this, I believe, is 1. And that, I believe, is 5. So that's 3, 4, and 2. Okay. And 1 is about here. And 2 is about here. And that's going to be 3. Okay. So let's draw our rectangles again. Okay. So remember that LRAM means I take whatever the value is at the left of my interval. And what's kind of happening there with my LRAM? Overestimating, underestimating? Under by a lot. Okay? We're missing all of this here and all of this here. Okay? So this is LRAM. Right. So no matter how big I make the interval, not the subinterval, but no matter how long I make my x-axis, it's going to keep underestimating. But what could I do to make it not underestimate? Increase the subintervals, okay, which we're not going to do right now. That's part of another problem. But let's take MRAM. Okay, so MRAM means I take the middle of my interval, and that's where I make my curve, or I make my rectangle. Yours may be slightly different. Depending on how accurately you sketched your curve. Okay. Now that's doing a little better, but we're still including whole areas here that aren't under our curve, and over here too, but we're really not missing as much. And then let's look at RRAM, which means we take the height of our triangle to be the value of the curve at the right side. So here's going to be my RRAM. Here's going to be my RRAM. And here's going to be my RRAM. So which of these do you think is going to give us the biggest value? MRAM. I'll even write it in green. And then what? Probably from the way we've drawn it, RRAM. I'm not sure if I've done it carefully enough. So why don't you actually run the RAM program again? Still 3 subintervals. And I think we find, I guess it does agree. Okay. Does it bear out? Zero. Because it's the same large interval. Yep, because it's the same window from 0 to 3. No, not really. I'm just estimating. And I had my calculator was set up so that the ticks on the x-axis were at 0, 1, 2, and 3. So on my calculator, I could kind of look up and see, okay, well, the tick for 1 is just about here, and the tick for 2 is just about here. So I wasn't cheating, I was just being observant. Okay, so do your answers for the RAM program agree with what we've got here? Excellent. Okay, so how about number 3? Somebody read us number 3. Okay. Well, air draw for me what a positive increasing function would look like. Okay, so something that goes up like that. So this is very much like the picture that we drew at the beginning. And in fact, I'm going to make it, just making it a little better. Okay. So if I took an LRAM and I used the left part, I'm going to get triangles that do what? Overestimate, right? Because I'm including all this area here that's not really under the curve. And my next one is going to look like this. So I'm always going to be adding area that isn't included under the curve. Okay? If I take RRAM, so that means I'm taking the height of my rectangle to be the value on the right, on the left. I'm sorry, did I screw that up? I did. That's why it was confusing. And that's why Maddie was looking at me funny. So this was RRAM, right? Is that it? Okay. So that's RRAM. So the RRAM is going to overestimate. The green is going to be the LRAM because I'm taking the height of my rectangle as the value of the curve on the left part of the subinterval. And is the LRAM going to overestimate or underestimate? Underestimate, because I've got all this area here that's not included. And then remember that MRAM means I choose the height of my rectangle as what's in the middle of the interval. So if I'm going to rank these, which one's going to be biggest? RRAM. And then what? Then MRAM. And LRAM is going to be at the end. And F is doing what here? Is increasing. Okay. So we got it? We'll understand what's happening here? Yes, everybody? Okay. So somebody read us number 4. Okay, so thank you. Somebody airdrop me a positive decreasing function. Yeah, okay. Which actually looks, whoops, a lot like this. Which was why the omniscient narrator pointed out that f of x was decreasing. So you know for number 4 that if you have a positive decreasing function, your LRAM is bigger than your MRAM is bigger than your RRAM. Okay, so we really use number 1 to answer number 4. Okay, we got it? We good? Everybody with me? Okay. So I'd like to try a couple problems. We'll get through at least one. We'll finish this section up tomorrow, and then on Friday we'll start 6.2. Okay. So let's do page 274, number 9. We're still going to use the RRAM program, so make sure you're next to somebody who has one. So somebody read for us, please. Okay, but what are the instructions, Gianni? You got to read the part above it. Less than or equal to. Thank you. Okay. So we've got a function, we've got an interval, and when you're going to run the RAM program, remember that before you start, you have to let y1, excuse me, be equal to f of x. So everybody set that up. And then we can run the RAM program. So go to Program, RAM. We're going to talk about that. So if we're going from 0 to 3, you're going to let capital A be 0 and capital B be 3. But a really good question is, what should we let n be? So let's start off with n equals 10. All right, and the whole idea here is we're going to see what happens to LRAM, MRAM, and RRAM as we let the number of subintervals increase. So if we start with 10, what are we going to get? So not really much agreement. Okay? They're pretty different answers. So let's increase the number of subintervals. Let's go to 50. So run the program again. Okay, is that what everybody got? Okay, so they're getting closer. They don't even agree to the 10th place though. So let's try something even bigger. Let's try n equals 100. 100 subintervals. It might take a little longer to do it. Maggie, I'm calling on you. What'd you get? This still running? Yep, that's okay. All right, so we're getting closer. Let's try 500. Still going? That's why we're going to stop at 500. All right, so if you had to give an answer for the area under the curve here, what would that answer be? Yeah. And if we put in more and more subintervals, if we made it 1,000, we'd be getting to even higher and higher values. Or, I'm sorry, we wouldn't. We would be getting to even closer and closer values. So I think we're going to stop here because the bell will ring. We will do some more examples tomorrow. Some we calculate by hand, some we'll calculate using the program. Okay?